All right. I've put up the, as per my usual habits, I've put up all the due dates up on the board. As you can tell, everything's due. Everything is due pretty much now. So you know.
Now?
No, well, not quite. Part of assignment 2 apparently disappeared 5 minutes ago. I made it reappear. It wasn't supposed to disappear till midnight. So assignment 2, part 2. For some unknown reason, Blackboard insisted on making it disappear at 5 to 5, which is no wrong. Yeah.
If we've already submitted.
Don't worry about it. The drop dead's midnight. In other words, after midnight, who's say yes.
Did you make a decision about lab 10?
About lab 10.
Yeah, because you weren't necessarily going to include it, or you're waiting for some kind of criteria.
I am debating on whether or not I'm going to just include it for bonus marks.
Okay.
At this point in time, I'm that far away from making it that way because you guys got obviously shorted one way, and my guys got shorted a different way because they literally were missing 2 whole lectures because Mondays.
Oh, right.
Right? There's a stat holiday, and then there's the start of the school year. But because of the way they did the start of the year this year, they also didn't get the first day of class either. So they actually were short 1 whole lab section as much as you guys were, except for 1 group of 28. So my lab 10 is sort of like floating out there, and I might just use it if you think you need the points. To up your lab points, not all your points. Right? So if you had problems with your lab, I might use that to bump up your lab values. All right? Hybrids, 4 to 7, they were due at midnight. Why? Because test 2 will appear in Blackboard for you guys at 6:30 tonight. I don't like people doing the test while I'm lecturing. It drives me insane. And you have until Sunday night, end of day. I will triple check those numbers, make sure nothing disappears on everybody. And it's going to drop dead next Thursday at end of day. That means December 1st after midnight, don't even bother asking to do it. Because the answer is going to be no. By then, I am now going to be elbows deep in grading and getting ready for the final exam. The practical is next week in lab, in your assigned lab section. The plan as described, and as far as I know, so to be fair, everybody gets the database and the diagram before the practical. I would recommend you familiarize yourself with the contents therein.
I was kind of surprised to see it today.
Eh?
I was kind of surprised to see it today.
Yeah, well, I was really surprised when I got the email 2 days ago. So I've made it available to all my sections now. So please try to understand what's in that diagram. I can now talk about it clearly. It is a flight database, and it is real data. That was actually out of a project. It's a database done for a project called Open Tracker. It was an open source airline flight tracker, and it's all real planes, real airports, real flight paths, the whole shooting match. Yeah, it's actually all real data. So there are lots and lots and lots of rows of data in there, and it's all pretty real. So that's that. I've had 2 teachers go through the test so far. 1 found a mistake, but the mistake was my answer. My question wasn't clear, not my answer. The answer was wrong. He punched in the wrong answer. So that's been rectified. It's taken the average teacher that have never seen it before about half an hour to 45 minutes to do. Now, that having been said, one of those teachers admittedly says SQL is not his strong point. Howard says SQL is not his strong point. He can use it, but not to the extent, say, Kumari and I can. When I did the test myself, knowing the database structure intimately, I did the test in 14 minutes. But I know the database intimately because I just finished rejigging the whole thing. The way I do the math was an expert in SQL should be able to do the test in 15 to 20 minutes. An intermediate user should do it under an hour. A student should take anywhere from an hour 20 to an hour 45, which is how long you guys have to do it. So it's been benchmarked, and I may, depending on how all the grades go, adjust if need be, just to be fair to everybody. You know, if more than half the class do horribly, I may have to adjust due to lack of time for people to practice. The practice test was put up. That practice test is last year's practical exam. So, my students have been through that one 3 times. There is no question like the last question on this practical exam. Just so you know, when you do that test, if you decide to do the test practical, and you get to the end, and you see that question worth 10 marks, there's none like that on this practical. There's no 10-point question. Just so you know. Considering that test was out of 21, but it was possible to get partial marks on that last question, depending on how badly or well you wrote your SQL, and whether or not you got nailed on distinctness of rows, that kind of stuff. Okay, so with that having been said, what are we doing today? This lecture went really fast with my guys on Monday, so we might all get out of here. Well, most of you will get out of here early. It's the last, pretty much, of the trigger lectures. I basically sit there and code up 2 sets of triggers so you guys can see how they're used. It'll show you a piece of every little bit of what's used in a trigger. And then that'll lead us to the point where we've actually dotted our T's and crossed our I's. Essentially, at this point, we've covered everything we're supposed to cover. I know you guys got the crash course version midterm, but we still technically covered everything. Next week's going to be a review. So I'm doing the review a little bit early. Usually I do it the last week. I'm going to do it 2 weeks ahead to give you guys a chance to percolate. And the last week will be used for Lab 10, and I do what I call the value added lectures. So there'll be a bunch of topics of interest, but not counting towards your education. All right, so I promised try to not make too many typos tonight. I butchered my demo on Monday. I hadn't touched the computer in 4 days at that point. My hands were not typing right. I'm hoping I do much better today. And just so you have a bit of background while this thing warms up and lights up, I'm starting with a virgin database that has no tables. I'm going to create the tables, create some triggers, add some data, and show you guys what happens when the data moves around. Yes?
Sorry, just before we go into the lecture, I wanted to ask, since I don't know if you mentioned it or not, the final exam, open book or not?
No.
Yeah. Okay.
No.
It's all written as well, right?
It's what?
Is it a written exam?
It is a paper-based Scantron job. I was going to cover what was in the exam next week, but it's multiple guess. Possible answers are from A to E. There's only ever one answer per question. So you have, the laws of stats say if you go B, 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 B all the way down, you still have a chance of passing. Not quite, that's not true. But yeah.
So were you able to do the hybrids over again for practice?
I will be releasing them shortly. I just need to capture the grades you've collected on them so that I know what you got as of the drop dead date, which will be, I will probably release them next Thursday. So you have a week to go through them again before the exam, which will force you to go through the textbook one more time. And also, as soon as the drop dead date appears for test 2, I have now learned how to make Blackboard actually show you all the answers after the test is no longer available to take. You learn something every week. And once that's done, it should all just fly. Hope for the best. All right, I guess I should aim this at myself. All right. As you can see, I've got my happy SQL window going with nothing in it. This is a completely virgin database. There are no tables whatsoever in it. And as usual, I'll create my table first. I'm already typing 100% better than I did on Monday. Okay, I created my first table. It's a customers table. Surprise, surprise. I work in business. 2 fields that are important, plus the primary key. There's an email field and a name field. I'll take a guess what goes into those. So pretend it's the custom table that's fully defined. There's all kinds of stuff in it, and then suddenly the marketing guy comes to you and hands you a big stack of paper on top of it says Pipeta. For those of you that don't know, that's Canada's Privacy Act. It sucks. Basically put, it's about 200 pages of contradictory statements about what you are not allowed to do. Except for now, we have to allow people to opt out of an email, so I suddenly have to alter my table. Like such. And I've had my opt-out column. So if I go, there should be nothing in there, just an empty table. Now, one of the other requirements of Pipeta is that you have to have proof of when somebody either subscribed or unsubscribed from your email list. You actually have to prove when he subscribed, unless it was before January 1st, 2015, I think it was. Then you don't have to prove it because the law wasn't in effect yet. It might have been January 1st, 2014. It's been a bit, so I've had to deal with it. But we have now provide to the CRTC, if they come knocking, proof of when an opt-in or an opt-out happened. And customers are required to actively select either in or out. You can't just make a default choice for them. So now I had to create a log. You know, I'm gonna have a really bad day today. It's not looking good. Like this. Now, realistically, I should be creating all the references and stuff. For now, I'm just going to skip that. Just make my life quick and easy. And hopefully I got it right. Hello. Okay, so I got my 2 tables, and they should both be empty. And they're both empty. Good. It's a good sign. No, I just created a table. I'd hoped there would be data in there. Stranger things have been known to happen.
Magic data.
Hey?
Magic data.
Magic data. Older computers had lots of magic data. So now, essentially, the easiest way to track whether or not something happens log-wise is to establish a trigger. And as a rule of thumb, you do your triggers as an after trigger. Why do you want to do it as an after trigger? Because you want to make sure that whatever you're doing to the data has been applied to the database. Therefore, if it successfully is able to be written, then you create the log entry. If it can't be written, it shouldn't be creating the log entry. Because then you're creating false positive data, and that's bad. As a rule of thumb, with organizations like the CRTC, you do not want to give them any more than you need to, because they get confused easy. Paper pushers. So we're going to create a trigger to handle the fact that the opt-in and opt-out is happening on a regular basis. And Postgres has a really interesting feature when it comes to creating triggers. And this is a feature it shares with a couple of other database servers, and it encourages code reuse. I don't know which instructor teaches you guys programming. Eh?
When one.
Okay, so because some of the people have Howard and some have Linda, and some people, there's a bunch of people teaching introductory programming. And one of the core tenets of object-oriented programming is code reuse. In other words, you don't want to keep reinventing the wheel over and over and over again. Don't worry about it. Windows 10 and video cards. when they're on a secondary display.
Yeah. Oh, is that what my problem is?
That's what it is.
Yeah.
Yeah, that's normal. All right, so now what's going to happen is I need to create a trigger. Now the way it works is that Postgres allows you to create a function and reuse it in more than one trigger. So that way you don't need to have 3 or 4 different triggers. Postgres allows it. Oracle sort of allows it. Microsoft SQL Server sort of allows it, depending on how you want to handle it. MySQL does not. You have to rewrite every trigger every time with MySQL. And you can't call other triggers MySQL. SAPDB allows it. So there's different allowances. So what you have to do first when you create a trigger in Postgres is you have to create the function first. And it's an interesting little experience when you do it, because the syntax is slightly different from the other create function. So I'm going to call it, just create and some database service allow or replace. This is really good when you're working with triggers and functions, so that you don't have to constantly drop your function. You can just create or replace. If it finds that it's already there, it just drops it and recreates it on the fly. See, I think the problem is I'm too far from the keyboard. Okay, a trigger function doesn't take parameters. It cannot accept parameters. But what it does do is it returns a trigger object. All right, so I've built my structure around my trigger function. And for this particular one, I don't need to create any variables. So I'm not going to skip the declare section. And I'm going to put in my code block, which is the begin and end. So all the magic is happening in here now. Now, since Postgres allows you to use the trigger in multiple places, you end up having to check what kind of action you're doing. And Postgres has a nifty little variable, you could call it, that it creates on the fly. I'm trying to find something equivalent in Java for you guys, but I can't think of one. Basically, it's a variable that's created by the system. So when you run whatever, you automatically get these variables. PHP is like that also.
Oh, like the time? I guess like
System
time.
variables.
Yeah, like there's system level variables or environment variables. I don't know if Java has environment variables. You probably call them through some system object. Postgres has a set of constants. As I said, the moment a trigger fires off, it establishes a series of constant values. And one of them is called TG-op, trigger operation. I'm going to make this a little bit bigger. Now, those of you that have seen language called BASIC, this looks familiar. Now, what I'm doing is I'm going to handle the two cases of either the update or the insert. And I'm just going to go with update and insert because, well, it's your choice of which one you want to do. You could do TG-ops equal insert, you just change your order of the stuff. And I'm going to do the insert one first, which is going to be down here. In actual fact, I can just go insert into, the heck did I call it, table? Email out, opt-out log. So right in the middle of my trigger, you see just a standard chunk of SQL. You guys have seen insert scenes before. There's nothing really new to see here. However, what's going to be coming into the values area here is what's going to be new. Literally, new. So I'm going to do an insert into my email opt-out log, and I'm going to insert the customer ID and whatever option of opt-out that they picked at that moment in time. And as you can see, there's something called new on both sides. New ID and new opt-out. This is part of the new data set that's being applied to the database. So on the fly, by now I think you guys probably covered arrays, right?
We're doing it right now.
Okay, so picture this sort of like an array. When the trigger fires off, it creates a couple of things. It creates the TG operators, and then TG op, what kind of operation is this? It also creates something called new and old. New contains an array of values that are being applied. Old is whatever was there before. And you access it by new dot property. So new ID, new name, new whatever. Then this will just do the insert. And I'm going to compile my thing, and it actually worked. That's new. Now, as you can see, I'm going to leave my trigger unfinished because I haven't handled the update yet. But I want to make sure my insert works, so I'll just go that way. But I need to create my trigger on my object now. So I'm going to go create trigger. Okay, I'm just going to double check, make sure I got it. I'm missing an important keyword. I knew I was. And I'll explain to you why I forgot that one in a second. So this is the syntax for creating a trigger. So you create trigger, give it a name, you tell it when it's going to fire, what its factor, what table it's attached to, and then you tell it for each row. I'll explain that in a minute. And then execute opt-out. Now this actually should be an after insert, actually, to be honest, so than logging. So I'm going to fire this one off and hope for the best. Okay, I didn't get an error. All right, so just go through the syntax again. Create trigger is obviously creating a trigger. So by now you would understand the concept of create object type, give it a name. You tell it when it's going to fire. You tell it what object it's firing on. For each row is the special keywords here now. What happens, let's say you're inserting 5 rows in one go. It means it's going to fire the trigger 5 times for each row being inserted. And then what it does, it executes the procedure that, in other words, the function I just created, every time you do an insert. If you choose to do a not for each row, it does what's called a global trigger. In other words, if you're doing an after insert and it's a global level trigger, it'll do all 5 inserts first and then fire the trigger once. So it's a post everything processing trigger, as opposed to after every insert process, every insert process. So that's basically what this is for. All right, so that's been created. So I'm going to do an insert into customers, name, email, opt out. I'm going to go values. Bob at bob.com. And he's going to opt out false. And this is always where the whole playing with Booleans gets irritating, right? Opt out false means he's opting in. It's a double negative. So I'm going to run this, and if we're really lucky, everything worked. And I forgot something. Now let me read, I don't know if those at the back can read how this small rank says, error, control reached end of trigger procedure without a return. When you do a trigger, it has to return something. You can't, you know, like in Java, you can have a void function that doesn't return something, but then you have other kinds of functions that have to return a data type. Triggers always have to return a trigger object. And right here before the end, I'd go return. And here you have the choice. You can return new, which is what was sent in. You could return old, what was there before. You can actually choose to not allow the update to happen by returning old if it's a before trigger. After trigger, you can return whatever the hell you want, nothing's going to happen. So I'm going to go return new. And I'm going to rerun my trigger, my function, I mean. And now the good news is I don't need to redo this. And now I just want to find the function it's calling. It's a bit like how you write a Java application, you write a Java program, right? You create your class, you create a method, and then you call that method somewhere. Later on, you may need to change your method you created. You don't need to change the call to it again. You just keep changing the method until it's done. And this is the same thing. So I'm going to do this one more time. I'm going to run it. And I got no error messages. On Monday, this took 5 tries. That's how bad I butchered it. So I'll go select everything for customers so you can see what's in there. There's Bob. And I'm going to select everything from email opt-out log, and there it is. I executed one insert statement. I got 2 rows of data. One in the primary table, and one to log the fact that I chose to opt in. Now I'll do another one here for, I don't know, Frank, and I'll make this one a true, just so you can see. And I'm going to go run. There's Frank, but he's opted in. And we're going to do another one here, and that one's opted in. Now, as you may suddenly realize, you look at this email opt-out log, and you'll notice that I'm doing something stupid.
No date.
Yeah, that's the one. Legally, I'm missing a date. And and I'm going to have my date. Now, you notice I set a default. What Postgres will do when you add a column, just so you know what I buy, if you set a default value, it will apply that to all the columns right away. It doesn't leave what was there before empty. So, just so that you know, they all get it. All right. So now I'm going to insert one more person so you can see that the timestamp is working. Jane, run it. And I know for a fact I know how to insert stuff, so I'm just going to check my second table. Now you can see that my timestamps are working and everything, so now we have all the legal requirements. So far I've done the insert. Now the catch is now, what happens if somebody updates and chooses to opt out? I'm not handling that case yet. So I need to come in here and add a bit more logic. Now there's one piece of logic that's important when you realize this. Do you want to enter a log about their opt-out status every single time they change their email address? No. Why? Because when you think about it, or let's say they change their name or they change their phone number, every single time you do an update, it would write an entry to the log. So you have to make sure that it's changing. So what you do is do a new if statement. So I'm doing a check here. This is where I'm going to take advantage of the new versus old. The new opt-out is not equal to the old opt-out. That means that the value of opt-out changed during that transaction. Otherwise, if this condition is not true, what's going to happen is it's just going to skip that and return out of the function and everything's happy. Why write more data than you don't need to? And then we can just literally grab this and put it in here. There's a few other ways of handling this. You could write this more efficiently so that there's only ever one insert statement. But that's, your choice. So I'm going to rebuild my trigger function. Done. Just going to make this a hair smaller. Now I need to create another trigger. Because I need to handle after I update the data also. Did that work? Yes, good. All right, so far I've proven the insert business. I'm going to do update customers, set opt out equal to true, where ID is equal to 1. So the first guy, I think, is opted in. So it's set to false. So I'm going to say, he said I don't want any more emails, so I'm going to run this. No error messages. Now if I run my opt-out log, and nothing happened. Yay. Cool. That was different. Let's try that again. Bang. That one's marked as false.
You don't have any ID one.
Yes, you're right. Hot damn, good job. But the best part is that I believe you made a message.
So 0 rows.
Yeah, all right, so I'm gonna make number 2 be opt-in instead. There we go, nothing affected. I'm gonna run this, and there's still nothing. Really? Let's take a look, see if it affected. Okay, ID is 2, it's false. ID 2 is gonna become true. See if I can actually not make a complete fool out of myself. Because I should be getting something happening. There we go. God, it helps if you pick all the right bits and pieces for the match. All right, here's our 2. So I'm actually going to modify this, go like this, and go, no, our customer ID is equal to true. Go, and now you can see where you opted in, then you opted out. So everything's happy, it's working. That's a basic trigger. And I'm going to open up Notepad here. So I can keep track of all these commands for you guys. So I can give it all to you later, all in one go. All right, so let me explain us a bit of what you see in here. After it takes the coffee. Okay, covers off. So up here, we're checking what kind of operation we're doing. Is it an insert and update? The cool part is now we can update this trigger, make changes to it to our heart's content, add rules, add extra logging. Maybe we want to capture what query actually triggered the update, that kind of stuff. So we have some extensive logging. Now this here is comparing the new data set to the old data set. Old's only available when you do an update. That's why it's contained inside the update. Otherwise, we could theoretically just have this everywhere and then be okay. So we have an if statement, and if then we do an insert, we're inserting the exact same thing. Then we do an else, where we insert. Then this is only whenever the record is first being created. It inserts in here. So in this example, you see how to do an insert into a secondary table. It shows you how to do a log. It shows you how to compare old to new values. It actually shows you how to do comparison operators, right? The if state, the good old if statement. I'm also showing you the use of the new object and the old object and the operator object. Now, not all database servers have the operator object. Like that, for example, MySQL does not have the operation object. Why? Because the triggers are contained inside the trigger itself. So instead of being a trigger calls a function, the trigger has all the code in it. So you can't reuse code. So let's say in this case I have this function to track opt-in and opt-out. I was able to create only one function. If I discover a bug, I need to fix it in one place. In MySQL, I'd have to put it on all the triggers if I had to do with customers. And in theory, in here we could also, I'd also tell you what table triggered it. There's an option for checking what table. You could write one function that, let's say it's a system like, how many of you have heard of Salesforce.com or Sugar CRM or customer relation management other than Salesforce? Yeah, I know, hotel guy.
CRMs.
It's a CRM, customer relation management system. Pretty much every corporation has one. It's what helps you keep track and touch base with your customers. And most of those systems have two kinds of entries, customers and leads. Leads are people who haven't bought anything from you yet, but you want to hunt them down to make money. The customers are people that have spent money on you, therefore you want to be nice to them too. You're bribing one side to come over and you're bribing the other side to stay with you. And what happens is, because of the stupid IPA law, we've had to track whenever a lead subscribes and unsubscribes, whenever a customer subscribes and unsubscribes. So what I ended up doing in that case at work is I created one giant trigger that handles both tables and all four operations. And I'm switching based on what table is being hit and on what the operation is, so I can actually do the proper checks. All right, so that's a logging, yes?
This might not be proper time, but would you also be able to use this with a little bit of expansion to track who made the change?
Depending on what kind of database authentication is being used. Now, a lot of systems have a last modified by field. So that would be part of the new data set. So usually you'll have a modified by ID of some sort that has to do with who did the change or who created the record. And that ID, you could just tag it along as part of the log table. So, change triggered by user ID this, and you just put it as part of this insert statement. Yes, totally, you could. But you have to make sure that all the bits and pieces are all there. You can track what query, at least Postgres you can. I'll actually show you guys at the end a trigger that's a little more beefy. That's actually a live trigger with the historical anecdote why it exists. It wasn't a happy time. Okay, so I've shown you guys the after trigger, the behavior of the after trigger, and it's doing the insert and the update. Now, you can also use triggers for rules, for setting and creating rules. And that sounds a little odd when I say that because you can create check constraints and that kind of stuff. But sometimes you want to make sure that the data can't be damaged. So I've saved this, so now I'm going to butcher my little trigger here. And I'm going to create a before and another before. And this one is I'm going to call this email check. And that's on insert. And that's on update. And now this is going to be called email check. Now you can see I'm doing a bunch of prep work. If you do all your prep work first, you make less mistakes and you get less errors. So if you place all your bits and pieces so that all your code structure is there, when it's not actually code, you don't have to worry about the mistakes around your structure. Okay, now, I'm gonna create a new rule that says, and I'm playing still with the opt-out business. Let's just say you don't trust your programmers. As a database designer, I rarely trust the programmer, none of the programmer. Because often what will happen is the database designer will be given an outline of what needs to happen. So it's a pretty good document that explains all the bits and pieces of the data, and they'll make their best design, and then it gets approved and done. The rules are set in stone how the data is. And then anybody who's ever worked in the computer industry has probably received the RFQ. And then after the RFQ, they send you this big stack of paper that says this is what the customer agreed to what's supposed to happen. And these are all the business rules for every single bit and piece. Especially if you work in the government or you work for very large corporations like IBM. Or when I worked for Digital and Compact, I once received an update request. The document was this thick, double-sided, about 105 pages long. And there was rule after rule after rule of all these little things. If you change this, this has to happen. If you change this, this has to happen. Now, as a database designer, you realize some of these rules, as was discussed in your document, but they were nice and short to the point. Not a lot of logic, just saying, you're not allowed to do this if this happens. And one of the rules should be, a person should not be able to opt into email if they don't have an email address. It's logical. Why allow, because a lot of these mailing software will say select email address from customers where opt-in is, well, false in this case, right? Then in other words, they mean that they've opted into the email. And then you end up with blank email addresses. So you end up having to add extra logic to your SQL statements, and some mail software doesn't handle that very gracefully. So you end up needing to add some extra rules. Now this is fairly straightforward. I'll create a new rule, actually an if statement, right? A conditional. I can go where new.email is null, or new.email is equal to empty, because null and empty is not the same thing, right? Null is the absence of information, empty is just an empty box where you can see inside the box. And new.optout is false. Now, if you remember, if somebody opts out and says, no, I have not opted out, that means they've opted in. There are stupid double negatives. So I'm saying if the opt-out is false, but they haven't given us an email address, set the opt-out to true. In other words, don't include them for Brian whenever we try to do a mailer. I'm showing you right here how to modify the data before it gets written to the database. I'll go through it. I'll go over it again in a minute. And I'm going to hit run and hope all the thing I wrote works. No error messages. Brilliant. So this is a rule that marks it as no matter what I do, it's always going to make sure the data is valid. Insert into customer name, comma, opt out, values, Joe, and false. In other words, Joe's opting in, and I'm going to run it and hope it all works. Try that again. No error message. Now I'm going to go select star from customers and go. Right here you can see Joe, no email address. Opt-out is true, but even though I fit it in, it's false because I forced the rule. Now, this will also work for an update. So if I go update customers, set email equal to this, where ID is equal to 3. And actually, I'm going to do the opt-out false. I'm going to run that. no errors. Gonna select everything. And you can see now that record 3 is no email address, and the opt-out is also set to true. That means that the rule kicked in. Now, some people don't like magic data. This falls under magic data. Anybody here know the meaning of magic data? Magic data is when data changes and you don't know why. You push a value, you say, okay, database, here's a value. And then you retrieve that record, it comes back and it's not what you sent in, and you go, what just happened? Dude, the data's screwed up. So then, of course, the programmer spends the next 3 days beating his head on the desk, trying to understand why the call to execute query is changing his data for him, because he wasn't aware that you applied a rule in the database. That was the first thing that went wrong. Because the programmer should have been told, the database will fix your mistakes for you. In some shops, this is considered a big no-no. Changing the data for someone else is considered a big no-no. They prefer you raise an exception. So in Java, you guys have probably learned about raising exceptions. Program runs, no? Okay, my guys learned about it. Heck, they're ahead of you guys for something else. And I think it's just by accident. Howard taught it to them by accident.
It's in our reading.
It's in your reading. Essentially, in Java, in PHP, there's a command called die. I love die. You go execute query or die. If the query fails, it actually exits the program with an error message. It's die. Perl has the same command. You kill the program with die. Python has kill. They have these nice aggressive words.
Kills standard Unix.
Yeah, kill kills the command. Kills the program dead right then and there. Exit, do not pass go, do not do garbage collection. Just ship the bed and quit. Now, Java has the same. It's just a little bit buried. C# has the same, as I'm discovering. So some people don't want this. They'll say, no, you're not allowed to do that. So actually, what I'm going to do first, I'm going to copy this so you have the full set. Because this kind of stuff's important, And I'm going to change my code here to raise exception. You cannot opt into emails. That's a nice clear error message, isn't it? I'm going to change my little function here. I'm going to run. And I'm going to try to update this guy. Bang. I get error. You cannot opt into emails. Now, if the programmer's too stupid to understand what just happened, there is no hope. But at least he won't be corrupting your database with bad data. You could also, some people prefer that you make a fake error code, Right? So we can always do this. There we go. Looks like the guy got a real error message. But we're calling him an idiot. Good old lady 10T error. It could be a pepcac error.
Could you also go back to the original and add a field and stick that message in the field why it changed it?
You could. You could do a system update messages. Heck, let's try. That's a question the guys on Monday didn't ask. Alter table customers, add column, last sys message text. Home. Now I'm going to just throw this trigger into over here, And I'm going to bring back this. Okay, so we're back to how the trigger was originally. Now you're saying, can we add another message? Yeah, we can go new dot last. The heck did I call it? Is this message? I think. Yeah. Data, opt-out data, automatically corrected due to there, like that. And I do this. I go run, like such. Now, if I try to do this, actually, first let's look at customers, so just so you can see. There's no last system message. And I'm going to try to break the rule again. No error message. So that's another way of doing it. At least the programmer is not completely in the dark of what happened. But if he doesn't know, then he could go look at that field. He's still doomed. And that's an ultimate solution. As you can see, actually this trigger, I like this trigger better than my original version. Let's see what I'm covering here. All right, so I'm checking right here a dual part condition, including brackets. You guys have seen that in Java, so that shouldn't be, the language looks different. The language is different, but the concept's exactly the same. If nothing else, basic syntax is actually easier to read than the Java syntax. So if the email is null or the email is equal to nothing, and opt-out is false, in other words, guys opting in. So you're not allowed to opt in if a customer does not have an email address. Then we're altering the data that's being passed in here, and we're creating new data. We're actually creating values for another field on the fly. We exit our conditional, we return new and others. We're returning the changes we just did here back to the trigger so that the trigger fires off, you modified what's about to be applied to the database, it gets written to the database, the after trigger fires off, puts in the logging, and that's it. These are basic examples of triggers. I mean, they can be significantly more complex, and depending, time permitting, the last lecture, depending what I decide to do, I might show you guys some inventory management style, where you're actually playing with quantities and availability and on hand and stuff. Sort of like what happens with Amazon. You know, you go to buy something on Amazon, they say they got 4 left available. You add it to your shopping cart, you check out, you go back, and there's 3 that are available. There's still 4 in the warehouse, but one's been allocated to you. And they're probably they're not using database triggers to do it because their database is massive. But they're using something similar to database triggers to handle the situation. All right, now, I am going to go pull up a trigger. So you guys have an idea of what another would use for triggers. No, not that one. Not that one. This one? No. This one. All right. I don't know if I told you guys this story last week. I don't think so. I did tell you guys about the Donald situation? Okay, so I had to tell that guys my money, so I guess you're going to be spared that story. Congratulations, I already told you. But yeah, that's the trigger that handles it. Specifically, it exploits one last function that I didn't show you guys. It's called current query. And this is a Postgres exclusive also. What this does, it detects what query activated the code. What triggered the trigger. So then you can search through your old code and find out where the SQL is coming from. So, but I guess I told you guys the story already, so you don't need the whole story again. But yeah, there's several triggers in this database here that do different things. This one here is to make sure the stuff got pushed up to Salesforce. That one is to trace different changes historically to dongles. There's all kinds of cool triggers. That's that. All right, so today, in summary, like I said, this one was short because we've hit everything we're supposed to cover. And there's no point doing a review quite yet because I'm not ready to do it. I gotta go reread the exam before I do the review. But today you've seen creating a before trigger, creating an after trigger. It showed you guys how to check what operation fired off the trigger. I showed you guys how to touch and check values in the new data set and or the old data set. And by the way, there's no point changing data in the old data set because it's defeating the point of the, there are cases though you could actually want to return the old data set. I've also shown you guys how to do two kinds of conditionals and how to reuse a trigger in multiple places. So it's a very short lecture that covers almost everything you can do with a trigger. There are a few other things you can do. And what I'll be doing is because my plan's a little flux for the last 2 weeks, depending on what I decide to do in the last week, if not, I will be giving you guys some examples of some more advanced triggers with comments in it explaining what's happening. Because you can actually run a query inside of this and loop through the results. So you can ask the database, give me some data, and then you can actually loop through those and actually apply changes or run updates or do multiple inserts in different places. Pardon?
Based on the data.
Yeah. And I have a set of 3 triggers that do that. That complete examples on how to modify another one. So other than that, I'm going to call it quits there. Like I said, this one was short, so everybody gets to go home early. Go have some supper. You don't need to starve. I will still be here for the tutoring session after class. Obviously, you guys